So we start the dielectric materials. Dielectrics are basically insulating material, but all those insulators cannot be dielectric materials. Then what is a specialty in the dielectric materials? The dielectric materials, where the electrons, where you don't have the free electrons, all the electrons are strongly bound to the atoms. Therefore, it behaves as electrically insulator. But under the influence of an external field, the molecule or the atom gets separated by a small distance. It will become a dipole. They get separate. The positive and negative charges of the atom or the molecule gets separated, and it will become a dipole. That happens in the dielectric materials. So all insulators cannot be dielectrics, but dielectric materials can be an insulator. So now in dielectrics, the atoms or the molecules, they get separated under the influence of an external field. That is the speciality. In insulators, you cannot expect the molecule to where the charges get separated. In dielectric materials, the charges get separated for a small distance. So the molecule becomes a dipole. So such a separated atom or a molecule is called as the dipole. So the dipoles have been created in the dielectric materials. Okay, now here it is called dielectric. Di means two. So what are the two possible charges? It's the positive and negative charges. So therefore, the plus and negative charges, they separated the two charges. Therefore, it is called dielectric materials. The dielectric material is an electrically insulating material. Example, glass, porcelain, wood, etc. So many other things. They are used to store charges. Here in dielectric materials, under the influence of an external field, the molecules, the atom becomes dipoles. What do you mean by dipoles? It represents the separation of positive negative charges. So it is single entity where positive negative charges get separated for a small distance. That is happens is in materials. Those materials are called the dielectric materials. But you cannot expect the same thing that is going to happen in all insulators. So all the dielectric materials where you don't see the free charge carriers or the electrons, all the electrons are strongly bound to the atoms or molecules. And you have seen that the medium between the two plates of the capacitor is called the dielectric medium. So, and you can increase the capacitance if you change the dielectric medium between the two plates of the capacitor. For example, if you introduce the glass, it increases the dielectricity by 7 times than that of the air. Okay, so now therefore the dielectric materials are used to store charges. So here the charges gets stored on the plates because of the dielectric medium, and hence there is increase in the overall charges that represents the storing capacity of the material. So now I told you that a dipole is a single entity where the positive and negative charges get separated by a small distance. And if you take the product of the one of the charge into the separated distance, separation of charges, distance of separation, then the product becomes the dipole moment. So dipole moment, it is a product of the one of the charge into the distance. Because of the electric field, the external electric field, the material, I told you, they gets polarized. What do you mean polarization? It represents the separation of charges over a small distance. So a dipole is an entity in which equal positive negative charges are separated by small distance. The distance of separation from the centers of positive negative charges is called the electric dipole. Don't confuse with the dipole and electric dipole. Dipole is a single entity where the charges get separated, that's all, by small distance. And in the case of electric dipole, it represents the distance of separation from the centers of positive negative charges. And now if that is, I told you the product of the electric dipole and one of the charges represents the dipole moment. So this dipole moment is once again see the dipole. How do you see the dipole? The direction of the dipole is always taken from the negative charges to positive charge. The electric field always taken from positive to negative. but the dipole, direction dipole is taken from negative charges to positive charges. The vector that points from negative to positive charges called the dipole moment here. The direction of the dipole moment is represented by a vector that is pointing from negative charge towards the positive charge. When you say before applying electric field, I told you dielectric materials, they are also insulators. Let us say you don't apply the electric field. Then, if you assume an atom, it is composed of the nucleus surrounded by the negative charges, the electrons. So the centers of positive charge and negative charges balances, and it nullifies the positive and negative effects. That is, the centers of positive and negative charges coincides, and hence the atom overall seems to be neutral state. If the positive and negative charge is separated, then it becomes the dipole. Okay, so here the unit of dipole is measured by given by 1 d by it is 3.33 into 10 to the power minus 30 coulomb. Say, look at the diagram. There is if you have a neutral atom where the centers of positive negative charges are coinciding, and you don't have the value for the dipole moment, that is centers of positive negative charges since they coincide. So the distance between, cannot expect the value of separation. It is completely zero because they are coinciding. In such cases, the dipole moment is zero. If the centers of two charges, centers of positive and negative charge coincides together, it neutralizes the effect, overall effect. Hence, you don't have the dipole moment. If the material, you apply the field externally, then charges get separated. Look at the middle one. So the positive and negative charges, they got separated for a small distance, and now it has become the dipole. So now the atom got the dipole moment only in the presence of the external field here. Okay, the process of the development of the charges of, that is on one side positive charges and other side the negative charges. The process of development of charges, or the process of development of the dipole moment in an atom or a molecule is called the polarization. What do you mean polarization? It is a process where the positive and negative charges, they got separated. The overall process of the development of the dipole moments in an atom or a molecule is called the polarization. So now we have seen that a capacitor, and many times we say that the medium between the two plates of the capacitor is called the dielectric medium, that has got certain value for it, a numerical value. If the plates of the capacitor is occupied by air, then it is represented by the dielectric constant of permittivity, relative permittivity epsilon naught is equal to 1, that is 1.006. That's the value. If suppose if you introduce some other material, glass, mica, porcelain, paper, etc., and so on, so you can increase the capacitance. You can increase the capacitance value of the capacitor. So you are introducing some material between the two plates of the capacitor, then you can increase the storing capacity of the material, the capacitor, by suitably changing the medium between the two plates of the capacitor. Now let us define the term dielectric constant or relative permittivity. How to define this? It is the ratio of the capacitance of the condenser with respect to air, with respect to the material, to the capacitance of a condenser with respect to the air or vacuum. It is the ratio of the capacitance of a condenser with respect to material to the capacitance of a condenser or a capacitor with respect to the air or vacuum. That ratio will give you the dielectric constant. It is also called relative permittivity. And this relative permittivity represents the factor that how much the value of capacitance can be increased by replacing the vacuum. You are replacing the vacuum or air by some material, isn't it? So this epsilon r relative permittivity with respect to the material, it tells us that it gives us how much the capacitance of a capacitor is increased introducing the material between the two plates of the capacitor. So the value of epsilon r, suppose if you say that the value of epsilon r is 5, then it tells us, so if you got air between the two plates of the capacitor, then the capacitance is around 1. If you now by introducing a material between the two plates of the capacitor, you got the capacitance, let us say 5 times. It means that you have increased the capacitance of a capacitor by 5 times with respect to the air or vacuum. Here I have produced a list of dielectric materials with certain dielectric constant. See, water has got 80.4 value for its dielectric constant, rubber got 6.7, Pyrex glass is 5.6, mica is 5.4, paper is 3.7, the other Teflon, etc. So this is the values of dielectric constant of certain dielectric substances. Coming to the types of dielectric materials, there are two types of dielectric materials. First one is non-polar dielectric materials. The second one is polar dielectric materials. What are non-polar dielectric materials? Here in non-polar dielectric materials, you don't see the in the absence of the electric field, you don't see the charges. You don't see the dipoles. The dipoles created only in the presence of the field. So in non-dipolar dielectric materials, the atoms or the molecules under consideration, they exhibit the neutrality condition. Why? Because the centers of the positive and negative charges. Centers of positive and negative means if the electrons and the nucleus, centers of positive and negative charges overlaps and it doesn't have the this dipole, electric dipole. So hence the no dipole moment. So non-polar dielectric materials are those materials where initially under the absence of the electric field you don't have the charges, I mean dipoles, because the centers of positive negative charges overlaps on each other, neutralizing the overall effect. Such materials are called the non-polar dielectric materials. So now under the influence of an external field, imagine you got a capacitor, two plates of the capacitor, and that is provided by an external field, electric field or potential, etc. Then because of the potential, and you got the medium between the two plates, the dielectric medium, there they where under the influence of external field, these charges get separated. Every molecule or atom where the charges are separated, and this will continue over the entire the material. Now look at the diagram there. So the plus and negative charges, I told you they got separated. The negative of the molecule A will overlap with the positive of the neighboring molecule B, and now this the negative of the molecule B overlaps with the positive of the neighboring molecule D, like that. So charges of opposite kinds of the neighboring molecules starts overlapping. What I am saying that, suppose you got a atom under the influence of electric potential, they got separated, positive, negative. Imagine there is another atom near to this atom number 1 that is also got separated, positive, negative. Imagine a third atom near to neighbor to atom 2, they also got separated. So now they take the first molecule number 1, the negative charges of the molecule 1 overlaps with the positive charges of the molecule 2, and the negative charges of the molecule 2 now overlaps the positive charges of the molecule 3. Like that it keeps continuing. So ultimately you will see that at the edges of the dielectric material you have one set of charges, let us say positive, and opposite to the other side you got the negative charges. So you don't have the charges further extra so that it can balance and neutralize the overall effect. So now ultimately because of the field applied here, you will find on the edges of the dielectric material, the charges got separated. So you got the charges got separated or accumulated on the opposite sides of the these dielectric materials. This will continue. So now, because of these charges, there creates a dipole moment. I told you that dipole moment, it is taken, the direction dipole moment is taken from negative to positive. At the edges of the dielectric materials, you got the one kind of charges. Two edges, one side you got positive charges and other side you got the negative charges. And that's how the charges they gets collected on the faces of the dielectric material. Okay.